Okay. I guess same directions determine where the derivative doesn't exist. I'll give you a hint. You need to convert this to a radical. Does anybody remember how to do that? 2/3 power. How does that become a radical? I'll write my radical out here. I'll give you a hint. The 3 is going to go one place and the 2 is going to go another place. Yeah. 3 right there for the root and 2 for the exponent. Now when we're taking the derivative, I misspoke there, we can keep it as a power to use the power rule. I was just pointing out with, whenever you have a radical, okay, a radical function basically is what we're dealing with, that's when you need to look out, that's why you need to look out for points where the derivative doesn't exist. But how do you take the derivative of x to the 2/3 using the power rule? You take this exponent and you make it the coefficient, right? And then you subtract 1 from it. So what's 2/3 minus 1? Negative 1/3, yes. So our derivative is going to be, I'm showing a lot of work here, you don't have to write any of this down. It's going to be 2/3 x to the negative 1/3. And if we rewrite that, because it's a negative exponent, it'd be 2/3x to the 1/3, okay? So we can again see that we have something in the denominator of our derivative function. So where do you think the point of discontinuity is going to be here? 3x to the 1/3 can't be equal to 0. What do you think x would be in order for it to be equal to 0? Yes, 0. If you divide both sides by 3 and take the cube root, you still just get 0 back, right? So x can't be equal to 0. Now we just need to figure out the y value of that point. So we're going to take that x value and plug it back into the original function. So 0 to any power is 0, so don't worry about the 2/3 and all that, right? It's still going to be 0, right? So 5 plus 0 is 0. So our point where the derivative is not going to exist is going to be 0, 5. And again, I want to show you what the graph of this looks like. I think this one's a cusp, I'm pretty sure. All right, here's our graph, and you can see a cusp coming in right there where those two curves meet. And that point is what? 0, 5, right? It's in between 4 and 6. It's on the y-axis. And that's the point we found where there is no tangent line, right? There's no way you could put your ruler on this and construct some kind of tangent line that would make sense. If anything, it would be vertical, which still confirms it doesn't exist, right? It's undefined.